Okay, so once again, very good morning all. So in the last lecture, we have started the problems on the type number one, that is the calculation of the shear stress, then torque transmitted by shaft and the power transmission capacity of the shaft. And in the yesterday's lecture, we have derived the derivation of the torsion formula, which we have to use for all the types of calculation. That is, T upon J is equal to tau upon R is equal to G theta by L. So that torsion formula we have derived in the yesterday's lecture. In addition to that, by using the same torsion formula, we have discussed about the two important formulas which are required for the torque transmission capacity, or it is also called as a strength of shaft. Means if we have to measure the strength of shaft, then that strength can be measured by using the torque transmitting capacity and the power transmitting capacity. Okay, and then in addition to these formulas, I have given the list of the formulas which are required to solve the problem based on the type number one. That is the power formula I have given, then the polar moment of inertia, which is called as a J for the solid shaft and hollow shaft. That two formulas also I have given, and also some basic things also I have explained which are required for the calculation. That is in the power formula, if we will keep the power in watt, then you will get the torque value in Newton meter, and then again you have to multiply by 10 raised to 3 and you have to convert in Newton mm. Okay, so these are the some basic things that we have discussed in the previous lecture, and based on that one numerical we have solved in the previous lecture related to the torque calculation. Okay, so again 2 to 3 numericals we will solve based on this particular type number one, that is the second problem is in front of you. Okay, so I will read the statement first and then we will solve it. Find the power that can be transmitted by the shaft of 60 mm diameter. So we have to calculate the power which is to be transmitted by that particular shaft, and that shaft is having the diameter of 60 mm. So if you see here, sometimes the word is mentioned the solid shaft, means there is only one diameter. Sometimes they are mentioning the word only shaft and having diameter 60 mm. The single diameter is given means you have to just think about that. Whatever the given shaft is there, it is solid in cross section. And for the solid shaft, only one diameter will be given. Okay, the 60 mm diameter and rotating at 180 rpm. So whatever the speed of the shaft is there, that is also given as 180 rpm. That means revolutions per minute. Full stop. If tau max is equal to 85 Newton per mm square. One shaft which is rotating at 180 rpm, its diameter is 60 mm and their maximum shear stress value is 85 Newton per mm square. If these are the conditions, then how much amount of power that shaft will transmit, that we have to calculate. Okay, so first of all, we just write down the given data. So the diameter of shaft is given 60 mm, that is solid shaft. Then speed, that is N. The speed of the rotating shaft will be represented by capital N and it is equal to 180 rpm. Then tau max, or it is also represented by tau, is equal to 85 Newton per mm square. 85 Newton per mm square, and we have to calculate the power. Okay, now as I have to calculate the power, I am having the power formula. What is that? P is equal to 2 pi nt divided by 60. So for the power calculation, this 2 into pi, these are the constant values. N, that is speed of the rotating shaft, is given as 180 rpm divided by 60. This is also constant parameter. Now we have to think about the torque. Now we have to think about the torque. That means for the power calculation, first of all, we need to calculate the torque transmitted by the shaft. And once I will calculate the torque transmitted by shaft, I will put that particular torque value in the power formula and then I will get the final answer. Okay, so this is the my requirement that I have to calculate. Now, if I have to calculate the torque value, the torque of the solid shaft, Which formula I have to use for the further calculation? Which formula I have
Pi
to
by
use?
16 into tau max into dq.
Correct. Pi by 16 into tau max into dq. This is the formula for the torque transmitting capacity of the solid shaft. So just put the values pi by 16 as it is into 85 into 20 cube. So capital T is equal to, what will be the torque?
60 cube na sir.
Pi by 16, sorry, 60 cube. Diameter is 60 mm. Then what will be value?
3.60 into 10 raised to 6.
3.60 into 10 raised to 6. This is the value in Newton mm. This is the value in Newton mm. Now we have to calculate the power in watt. Then what we have to do here? We have to calculate the power in watt, and in the power formula, in order to calculate the power in watt, what is the requirement of torque? What is the requirement of torque? Whether we have to take this Newton mm value as it is?
Newton meter.
Newton meter, because as I have explained in the previous lecture, that is, while calculating the torque from the power formula, if the power is given in watt, then you will get the torque value in Newton meter. And now it is exactly opposite. Now I have to calculate the power. Power जर फाइंड आउट करायची असेल तर दिलेल्या त्या फॉर्म्युलेमध्ये टॉर्क आपल्याला कसा पुट करावा लागेल, तर न्यूटन मीटर मध्येच पुट करावा लागेल. Therefore capital T is equal to 3.60 into, इथं न्यूटन mm आहे. जर ह्याला आपल्याला न्यूटन मीटर करायचं असेल तर डिवाइड बाय 10⁻³ करावं लागणार, म्हणजे इथं यू विल गेट द 10⁻³ न्यूटन meter. Now check your torque value whether you will get this 3.60 into 10⁻⁶ Newton mm. But I want that value in Newton meter because we have to calculate the power in watt. So whatever the value you have calculated, त्या व्हॅल्यूला आपल्याला काय करावं लागणार आहे, 10⁻³ न डिवाइड करावं लागणार आहे. जर 10⁻³ ने डिवाइड केलं तर त्या 10⁻³ from the numerator and denominator it will get cancelled. Okay, त्यामुळे 3.60 into 10⁻³. This value you will get as a torque transmitted by the solid shaft. Please check your answers. The calculation is very simple. And if you have calculated this value, again use our power formula. P is equal to 2 pi n t divided by 60, which is equal to 2 into pi into 180 into torque. You have to put in Newton meter, 360 into 10⁻³ divided by 60. So what will be the answer?
67.85 into
6.78 into 10 raised
10⁻³.
to
67.85 into 10⁻³
3.
This is watt, and same value we can write in the form of kilowatt, that is 67.85 kilowatt. So this is the answer. Please check your answer. Calculation is very simple. Only we have to apply some normal concepts while doing the calculations, and then we will get the correct answers. Don't forget to convert the torque value from Newton mm to Newton meter. If you forget and if you keep that value as it is in the power formula, your answer will be wrong. Please keep in mind. So once you will get the answer, immediately you have to go for the conversion. Like that, we have to follow the practice. And these are the small numericals. It will ask for your online MCQ examination also. Problem will be given as a statement. You have to solve the rough problem, and the 4 options are given in the form of final answer, and from that 4 options you have to select the correct answer. So for that purpose your correct calculation is required. Check the torque value and then check the power value. 67.85 into 10⁻³ watt. That same value I have written in the form of kilowatt. Do the calculation, all of you. Calculation is very simple. Sometimes you are able to do the calculation, but you are neglecting the calculation part. Small mistakes you are doing the calculation, and due to which your answer will be wrong. So try to follow the standard practice. Step by step you have to follow the procedure, and you have to do the calculations, and you have to check, you have to verify your answer. So 67.85 into 10 raised to 3 watt, this much amount of power is transmitted by the solid shaft. So by using this particular power value and by using this particular torque value, we can check the strength of the shaft, because while checking the strength of the shaft, maximum focus we are giving on the torque transmission capacity and the power transmission capacity. जेवढ्या ह्या व्हॅल्यू जास्त असतील तेवढा शाफ्ट तुमचा मॅक्सिमम लोड काय करणार आहे, सस्टेन करणार आहे, और इट विल बी कंटिन्युअसली इन वर्किंग कंडिशन. If there is a possibility of failure, means we can say that their torque transmitting capacity is less, means the strength of the shaft is also very less. Okay, so for that purpose here you have to read the statement carefully. First of all you have to read the statement carefully and then think for few minutes, for few seconds, think which formula we have to use for the calculation. Sometimes we are able to remind all the list of the formulas, सगळे फॉर्म्युला आपल्याला तोंडपाठ असतात, but we are unable to understand the statement. त्या स्टेटमेंट मध्ये काय दिलेलं आहे, कुठले पॅरामीटर दिलेले आहेत आणि काय काढायचं आहे, आणि तो काढण्यासाठी आपल्याला नेमका कुठला फॉर्म्युला वापरायचा आहे, that we are unable to remind. So first of all, read the statement carefully, check the given data. कारण related to the 80 to 90% problem, we have to check through the given data. जो काही given data दिलेला असतो त्या given data नुसारच आपल्याला समजतं की which formula we have to use for the further calculation. Therefore, take your time, read the statement carefully, write down the given data, don't solve the problem directly. Write down the given data separately, and then go for the further solution by using the list of the formulas. Okay, I hope you have calculated this. The problem number 1, we have calculated the torque transmitting capacity. Now this is the problem number 2. We have calculated the torque transmitting capacity as well as we have calculated their power transmission also. Okay, now the third problem, it is somewhat different. In the problem number 1 we have calculated torque. In the problem number 2 we have calculated torque as well as power, and now problem number 3 is somewhat different. If you read, see, a hollow shaft, the statement is starting with the type of shaft, that is a hollow shaft of 25 mm outer diameter, a hollow shaft of 25 mm outer diameter and 20 mm internal diameter. Two diameters are given, means the shaft given as a hollow in cross section. So 25 mm external diameter, which is also called as the outer diameter, 20 mm internal diameter, subjected to a torque of 50 Newton meter. The shaft is transmitting the torque of 50 Newton meter, full stop. Find stresses at outer and inner diameter of shaft. Find stresses means here we have to calculate only one stress, which is called as a shear stress. Sometimes they are mentioning the word like find shear stresses at outer diameter and inner diameter of shaft. But if they have not mentioned the word shear, means you have to just clear that, or we have to just understand that whatever the stress we have to calculate, that stress will be the shear only. Okay, so this is the statement in front of you. If you read, the hollow shaft is there, that hollow shaft is having the two diameters and it is transmitting the torque. तो shaft किती torque transmit करतोय, that torque value also given in the statement. आतापर्यंतच्या दोन प्रॉब्लेम मध्ये आपल्याला torque transmitting capacity काढायला सांगितली होती, आणि त्याच्यामध्ये दोन्ही स्टेटमेंट मध्ये in both the statements, if you see, the maximum shear stress value is given as 85. In the problem number 1, it is given as a 180 Newton per mm square. But here the torque is given and we have to calculate the shear stresses. But in addition to that, we have to calculate the separate shear stress value at the outer diameter and the separate shear stress value at the internal diameter. Means both shear stress value we have to calculate. Why we have to calculate at outside and why we have to calculate inside? Because this is the hollow shaft and having the two diameters. म्हणजे shaftच्या बाहेरच्या बाजूला पण एक वेगळा स्ट्रेस इंड्यूस होणार आहे आणि shaftच्या आतल्या बाजूला पण एक वेगळा स्ट्रेस इंड्यूस होणार आहे. And that two values we have to calculate. Now if I will write down the given parameter first. How to calculate it? See. Capital DO means outside diameter 25 mm. DI that is internal diameter 20 mm. Torque is equal to 50 Newton meter. Okay, already it is given in Newton, but second is meter. So you have to convert that meter value into mm. That is 50 into 10 raised to 3 Newton. And what we have to calculate? We have to calculate the shear stress. The shear stress is indicated by tau, and we have to calculate at outer diameter means tau O. We have to calculate, and internal diameter means tau I. We have to calculate. So these are the two shear stress values we have to calculate for this particular hollow shaft. Okay, then how it is to be calculated? This is the hollow shaft. So you are having the one common formula. See, we are having one common formula. So first, shear stress at outer diameter, that is du. So I will write our common torsion formula. T upon J is equal to tau upon R is equal to G theta by L. If you read our statement, and in that particular statement, the value of G they have not mentioned, value of theta they have not mentioned, value of length they have not mentioned. Therefore, there is no use of this particular third parameters, that is G theta by L. This value will not be applicable for our further calculation. So I will take only first two terms, that is T upon J is equal to tau upon R. T upon J is equal to tau upon R. So T upon J is equal to tau upon R. Now I have to write this particular formula for the outer diameter only. Whatever the torque is given 50 Newton per meter, this torque is applicable for the whole shaft. This torque is applicable for the whole shaft, that is for hollow shaft. It is not applicable only for the outer diameter, it is not applicable for only internal diameter. So that will be applicable for the total shaft. And now I am having this particular torsion formula, that is T upon J is equal to tau upon R. Okay. If I have to write this particular formula in the form of outer diameter only, then where we have to make the changes? Where we have to make the changes?
Radius.
Okay, radius. Then radius, outer radius. Then see T upon JO is equal to tau O upon RO. T is the constant. Okay. J means polar moment of inertia. What is the polar moment of inertia for the? We are calculating the parameter for outer diameter. आपण शियर स्ट्रेस कुठल्या ह्याला काढतोय तर सध्या आउटर डायमीटरला काढतोय, त्यामुळे त्या ठिकाणी जो काय पोलर मोमेंट ऑफ इनर्शिया घ्यायचा तो पण पोलर मोमेंट इनर्शिया आपल्याला आउटर डायमीटरचाच घ्यावा लागणार आहे. ओके, देयरफॉर tau o jo tau o, this is our unknown parameter, that is shear stress at outer diameter we have to calculate, and then radius ro, because we are calculating for the external diameter. Now put the values. It is very simple. T is equal to 50 into 10 raised to 3 divided by pi by 32 into jo means do raised to 4 means 25 raised to 4. Tau o we have to calculate, divided by ro. Diameter is given 25. Then what will be your radius?
12.5.
25 divided by 2 means 12.5, and through this calculation you will get the shear stress at outer radius only. Sorry. So what will be the answer? Shear stress at outer radius. Do the calculation. All the parameters are given. Do the separate calculation of pi by 32 into do raised to 4. That is 25 raised to 4. What will be the shear stress value for the outer radius? Similarly, here I will write down the second formula also, that is shear stress at internal diameter, that is di. Therefore, T upon J is equal to tau upon R. Therefore, T upon Ji is equal to tau I divided by Ri. So once again, 50 into 10 raised to 3 as it is, divided by Ji means internal diameter, pi by 32 into 20 raised to 4 is equal to tau I we have to calculate, and Ri means diameter is 20 mm, means it becomes 10. Therefore, tau I is equal to. So what will be the tau O?
16.29.
16.25.
16.29 Newton per mm square. 16.28 or 16.28, 26.29, this is long. 26.29, this is wrong. 16.29, 16.25 or 16.28 Newton per mm square. That answer will be correct. 16.29 or 16.25, 16.30. That answer will be correct. So this is the tau O, which is developed at the outer diameter only. ह्या shear stress ची व्हॅल्यू फक्त outer diameter लाच असणार आहे. Then what will be the tau I?
31.83.
31.83. Now if we compare both the stress values, the tau I, that is shear stress at internal diameter, is maximum. What is the reason behind this? Tau I is minimum and tau O is maximum. What is the reason?
Area is less at internal.
Correct. Again, here we have to apply our concept, that is stress is maximum where area is minimum. Where stress is maximum? At the internal diameter. Why it is less area? Because if we compare both diameters, that is 25 mm and 20 mm, 20 mm is less than 25. मग diameter जर कमी येत असेल तर त्याच्यामुळे येणारा एरिया पण काय असणार आहे, कमी असणार आहे, आणि जर एरियाची व्हॅल्यू कमी येत असेल तर त्या ठिकाणी इंड्यूस झालेली स्ट्रेस व्हॅल्यू काय असणार आहे, मॅक्सिमम असणार आहे. That is, stress is maximum where area is minimum. मग त्याच पद्धतीने shear stress, that is tau O, ह्या ठिकाणी डायमीटर किती आहे, 25 mm, which is greater than 20 mm. 25 mm is greater than 20 mm means outer diameterचा एरिया काय असणार आहे, मॅक्सिमम असणार आहे. जर त्या ठिकाणी एरिया जर मॅक्सिमम येत असेल तर तुमची स्ट्रेस व्हॅल्यू काय होणार आहे, त्या ठिकाणी कमी होणार आहे. So again here our conditions are satisfied, that is stress is maximum where area is minimum and stress is minimum where area is maximum. And here we have compared both the areas from their diameters. So like that also we can verify your answers whether our calculated answers are correct or not. जर तुमची टाऊ I shear stress at internal diameter value टाऊ पेक्षा जर जास्त आली तर something wrong calculation you have made, that you have to understood. Variations in the points 31.82, 31.81, 31.85, like that variations will be accepted, but that value should be greater than tau o because we have to satisfy our conditions. Okay, so this is the one problem where we have calculated the shear stress. So in the type number 1 we are having these three types of varieties there. That is, the shear stress will be given, diameters are given, and we have to calculate either torque transmitting capacity. In addition to the torque transmitting capacity, we have to calculate their power transmission capacity, and based on this we have solved the problem number 1 and the problem number 2. Now the problem number 3 is exactly opposite. Problem number 3 is exactly opposite, where they have given the torque transmitting capacity of total shaft. The torque transmitting capacity is not applicable for the outer diameter and inner diameter. इवन शाफ्ट जरी हॉलो असेल किंवा शाफ्ट जरी सॉलिड असेल तर त्यात पूर्ण शाफ्टसाठी एकच टॉर्क ट्रान्समिटिंग कॅपॅसिटी असते. आउटर डायमीटरला वेगळा टॉर्क आणि इंटरनल डायमीटरला वेगळा टॉर्क. इट विल नॉट बी लाईक दॅट. Therefore, the third problem is exactly opposite than the problem number 1 and 2, where the torque is given and they have asked to find out the separate shear stress value at the outer diameter and the separate shear stress value at the internal diameter. So this is the problem based on the shear stress calculation. If they will ask, find out the maximum shear stress induced in the shaft. आत्ताच्या स्टेटमेंट मध्ये काय विचारले त्यांनी, फाइंड आउट द स्ट्रेस ऍट आउटर डायमीटर अँड इंटरनल डायमीटर. देअरफॉर यू विल गेट द टू shear stress values, one as outer diameter and another at internal diameter. But if they will ask the problem like this, find out the maximum shear stress induced in the shaft, then your formula will becomes like that: T upon J is equal to tau upon R. And in that T value I can put J means pi by 32 into do raised to 4 minus dr raised to 4 is equal to tau divided by हितला R म्हणजे कुठला घेणार आहे हॉलो शाफ्ट साठी सांगा आता मला. कॅपिटल R जो आहे तो कशाने रिप्लेस करणार आपण, RO or RI. फॉर द हॉलो शाफ्ट ह्या टॉर्शनच्या फॉर्म्युलेमध्ये जो काही कॅपिटल R आहे दॅट विल बी रिप्लेस्ड बाय कॅपिटल RO और कॅपिटल RI.
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 The torque value is always maximum at the outer periphery. What is the answer?
RO.
RO is RO. Always your torque transmitting capacity is always maximum at the outer periphery. मग outer periphery म्हणजे शाफ्टचा कुठला डायमीटर आपल्याला कन्सिडर करणार आहे, बाहेरचा डायमीटर. जर तो सॉलिड शाफ्ट असेल तर त्या ठिकाणी एकच डायमीटर असतो, त्या ठिकाणी दुसऱ्या डायमीटरचा संबंध येतच नाही. बट इफ देयर इज अ हॉलो शाफ्ट, त्या हॉलो शाफ्ट मध्ये ह्या टॉर्शनच्या फॉर्म्युलेमध्ये जर आपल्याला कॅपिटल R ची व्हॅल्यू जर रिप्लेस करायची असेल तर दॅट विल बी रिप्लेस्ड बाय कॅपिटल RO ओनली, बिकॉज इन केस ऑफ ए हॉलो शाफ्ट also the torque is maximum at outer periphery. Please keep in mind, this is very very important. By mistake if you will take the RI value it will be wrong. ठीक आहे. मग हा टाऊ काढतोय म्हणजे आपण हा काय काढतोय तर ह्या टोटल शाफ्ट मध्ये इंड्यूस झालेला मॅक्सिमम स्ट्रेस आपण ह्या फॉर्म्युल्यानं काढू शकतो. दिस विल बी रिप्रेझेंट द मॅक्सिमम टॉर्क इंड्यूस्ड इन दिस पर्टिक्युलर शाफ्ट. गेटिंग. मग ह्या ठिकाणी बघा पाय बाय 32 DO raised to 4 minus DR raised to 4 म्हणजे टोटल दोन्ही डायमीटरचा इफेक्ट आपण पोलर मोमेंट ऑफ इनर्शिया मध्ये काय केलेला आहे, कन्सिडर केलेला आहे. पण आपण कॅल्क्युलेशन काय केलंय, दे हॅव आस्क्ड सेपरेट स्ट्रेस फॉर द आउटर डायमीटर. मग आउटर डायमीटरलाच काढायचं असल्यामुळे त्या ठिकाणी आपण फक्त एकच डायमीटर कॅल्क्युलेशन मध्ये इफेक्ट कन्सिडर केला. इंटरनल डायमीटरलाच काढायचं म्हणून त्या ठिकाणी आपण एकच इंटरनल डायमीटर कॅल्क्युलेशन मध्ये कन्सिडर केलं. But if they will ask the question, find out the maximum shear stress in the shaft. In that case, we have to consider effect of both diameters in the J. That is pi by 32 capital DO raised to 4 minus DR raised to 4 is equal to tau max, and this capital R will be replaced by RO only. जरी आपण टोटल shear stress काढत असेल तरी पण कॅल्क्युलेशन मध्ये मॅक्सिमम डायमीटरचा इफेक्टच ह्या फॉर्म्युलेमध्ये आपल्याला काय करायचं आहे, कन्सिडर करायचं आहे. Therefore, capital R will be replaced by RO. That thing you have to keep in mind. Getting? So these are the third problem based on the shear stress calculation, where we have calculated separate shear stress value for the outer diameter and the internal diameter. And if they will ask common shear stress value for the total shaft, then you have to use the same formula. हाच फॉर्म्युला यूज केलाय. फक्त इकडे लिहिताना मी काय केलेले आहेत, दोन फॉर्म्युले एक आउटर डायमीटरच्या फॉर्म मध्ये लिहिले आहेत आणि तोच फॉर्म्युला फक्त इंटरनलच्या फॉर्म मध्ये लिहिले. म्हणजे कुठं टी अपॉन टाय ji divided by tau I divided by ri. तसंच t upon jo divided by tau u divided by r. But here t upon j divided by tau upon. So like that we have to make the changes. Okay, so these are the problems based on the type number 1. Now we'll move to the type number 2, and this is very important. So type number 1 is important for your MCQ examination. So little bit small problems are also asked in your MCQ examinations. You have to do the rough calculation, because if you do this particular calculation within 1 minute, we can do the calculation and you can choose the correct answer from the 4 options. Okay, but now the type number 2, it is related to the design of shaft. So what is meant by the design of shaft? Sorry. What is meant by the design of shaft? Design of shaft means calculation of shaft diameters. See, design of the shaft is the different parameter, and checking the strength of shaft, this is the different concept. Two concepts are totally different. Design of shaft is different and checking the strength of shaft is different. Already we have discussed, if we have to check the strength of the shaft, then we are calculating only two parameters as per our requirement, either capital T or either capital P, that is power transmission capacity, and capital T means torque transmission capacity. And from that we are checking the strength of the shaft, whether that strength of the shaft is high, medium or low. But design of shaft is totally different. And in the design of the shaft, we are focusing on the calculation of diameters. We are focusing on the calculation of shaft diameters. If the shaft is solid, then we are calculating only one diameter as a capital D. If the shaft is hollow, then we have to calculate the two diameters. One is external diameter and second is internal diameter. Why this particular design of the shaft is required? Because you are having so many applications. Shaft is having so many applications. Shaft can be used in the 2-wheelers, 4-wheelers. It can be used in the different machines or in any structure, in motors, pulleys, vehicles. In any structure, the shaft can be used. But in all this particular application, the shaft diameter will not remain constant. In all these application, shaft diameter will not be constant. For example, in the lathe machine, the shaft diameters will be different and it is designed as per the requirement of the machine. जर एखाद्या lathe machine मध्ये मला 30 mm diameter जर shaft वापरायचा असेल, तर that we have designed, this is my requirement, कारण ह्या application साठी मला 30 mm diameter चा shaft मला वापरायचा आहे, and that's why I have designed that particular shaft having diameter 30 mm. In case of a 4-wheeler vehicle, whatever the axle is there, front axle or rear axle, that diameter is, for example, 50 mm. This is my requirement because this is design. That particular 4-wheeler vehicle is having that requirement, that is 50 mm diameter can sustain the maximum load. Again, the shaft diameter will get changed. Again, in lathe application, shaft diameter will be different. In another application, shaft diameter will be different. That means in number of applications, the shaft diameters are variable, and according to that particular application, if we have to design the shaft, प्रत्येक applicationची requirement वेगवेगळी आहे. जर requirement जर वेगवेगळी असेल तर त्या ठिकाणी तुम्हाला वेगवेगळ्या डायमीटरचे shaft काय करावे लागणार आहेत, वापरावे लागणार आहेत. Means what I have to do? I have to design that particular shaft for the particular application. मग त्या particular application ला जर आपल्याला shaft design करायचा असेल तर त्या ठिकाणी त्या particular application साठी किती diameterचा shaft आपल्याला design करावा लागेल, that we have to calculate. Means that concept is called as a design of shaft. मग तो shaft design करण्यासाठी initially The requirement is that we have to know the torque transmitting capacity, we have to know the shear stress of that particular shaft. जर तुम्हाला एखाद्या शाफ्टचा डायमीटर डिझाइन करायचा असेल किंवा एखाद्या शाफ्टचा डायमीटर तुम्हाला फाइंड आउट करायचे असतील तर बिफोर दिस डायमीटर कॅल्क्युलेशन व्हॉट इज माय फर्स्ट रिक्वायरमेंट I have to know their torque transmitting capacity or power transmitting capacity or maximum shear stress induced in the shaft. म्हणजे फॉर एक्झाम्पल बघा जर लेथ मशीन मध्ये जर मला एक 50 mm डायमीटरचा शाफ्ट जर डिझाइन करायचा असेल तर तो 50 mm डायमीटरचा शाफ्ट डिझाइन करण्याच्या अगोदर त्या 50 mm डायमीटरच्या शाफ्टनं किती टॉर्क ट्रान्समिट केला पाहिजे दॅट आल्सो आय हॅव टू कॅल्क्युलेट किंवा त्याच 50 mm डायमीटरच्या शाफ्टनं किती पॉवर ट्रान्समिट केली पाहिजे that also I have to calculate. And in addition to that, for same 50 mm diameter shaft, how much amount of shear stress that shaft will sustain, that is what is the tau max value of that particular shaft, that also I have to calculate. If I am able to calculate this parameter, then and then only I can go further and I can calculate the diameter of the shaft. For example, torque is the 50 Newton mm. Okay, maximum shear stress is 85 Newton per mm square. So for these two parameters, जर torque 50 Newton mm असेल, maximum shear stress हा 85 Newton per mm square असेल, तर ह्या पॅरामीटर साठी किती डायमीटरचा शाफ्ट आपल्याला डिझाइन करावे लागेल that we are calculating means we are designing the shaft for the particular application. And the shaft parameter or the diameters or the design of the shaft can be designed based on the two concepts. The design of the shaft can be diameter of the shaft can be calculated by using the two parameters, and that will be done by using the two formulas. The first formula is in front of you, second formula is also in front of you, and for that purpose, if you see our torsion formula, T upon J is equal to tau upon R is equal to G theta by L. Same formula we have to use for the design of the shaft, but in two different conditions. Same torsion formula we have to use for the design of the shaft, but in two different conditions. What are that condition? If you see the first equation, T upon J is equal to tau upon R. So this particular formula will be applicable for the design of the shaft where it is based on shear stress concept. Means the design of the shaft or the diameter calculation of the shaft based on the maximum shear stress induced in the shaft. म्हणजे shear stress चा वापर करून पण आपल्याला shaft diameter काय करावा लागतो फाइंड आउट करावा लागतो. And then what is the second formula? T upon J and T upon J. This is common for the formula number 1 and formula number 2. If you see T upon J for the equation number 1, T upon J for the equation number 2. Because without torque calculation we are unable to do the further calculation. त्यामुळे दोन्ही फॉर्म्युले मध्ये टॉर्कचा इफेक्ट आपल्याला काय करावा लागणार आहे कन्सिडर करावा लागणार आहे. Therefore T upon J it is common, and tau upon R is applicable for only formula number 1 because here design of the shaft will be carried out by using the shear stress concept only. And then what is the second formula? T upon J is equal to G theta by L. And what this particular formula indicates, that is design of shaft based on angle of twist, because here theta is present. Second combination मध्ये theta is present, therefore the design of the shaft is based on angle of twist. Means we can design your shaft by using the concept of the shear stress or by using the concept of angle of twist. That you have to keep in mind. And one thing also you have to then what is the variation through this particular calculation? You will get one diameter by using the formula number 1 also, that is T upon J is equal to tau upon R. म्हणजे मॅक्सिमम shear stress चा वापर करून पण आपल्याला एक डायमीटर मिळेल. आणि by using the second formula also you will get the diameter. Then which diameter we have to consider? Which diameter we have to consider? After comparing both the values or after comparing both the answers, the maximum value of the diameter we have to consider for the further application. कारण जेवढा तुमचा डायमीटर हा मॅक्सिमम असणार आहे तेवढा तुमचा क्रॉस सेक्शनल एरिया हा वाढणार आहे आणि जेवढा क्रॉस सेक्शनल एरिया तुमचा जास्त असणार आहे तेवढा तुमचं त्या शाफ्टची पॉवर ट्रान्समिटिंग कॅपॅसिटी वाढणार आहे, टॉर्क ट्रान्समिटिंग कॅपॅसिटी वाढणार. दॅट मीन्स विदाउट एनी फेल्युअर द शाफ्ट कॅन ट्रान्समिट the maximum power. So this is the requirement. Therefore, sometimes in the statement they are mentioning only shear stress. They are mentioning only shear stress. So that problem we have to solve by using the formula number 1 only. And you will get only one diameter and that diameter will be final. जर दिलेल्या स्टेटमेंट मध्ये फक्त shear stressची व्हॅल्यू दिली असेल तर हाच फॉर्म्युला वापरून तुम्हाला डायमीटर काढायचा आहे and that diameter will be final for your final application. But sometimes in the same statement त्याच स्टेटमेंट मध्ये shear stress पण इंडिकेट केलेला असतो आणि थीटाची व्हॅल्यू पण इंडिकेट केलेली असते. Then we have to calculate the diameters by using the formula number 1 and by using the formula number 2 also. फॉर्म्युला नंबर 1 चा वापर करून पण तुम्हाला एक डायमीटर येईल, फॉर्म्युला नंबर 2 चा वापर करून पण तुम्हाला एक डायमीटर येईल. मग ते दोन्ही डायमीटर एकमेकाला कंपेअर करा आणि त्या दोन्ही डायमीटर मध्ये जी काय मॅक्सिमम डायमीटर व्हॅल्यू आहे दॅट वी हॅव टू कन्सिडर फॉर युअर फर्दर ऍप्लिकेशन. फॉर एक्झाम्पल पहिल्याचा 49 आला आणि दुसऱ्याचा 50 आला, 50 diameter for the solid shaft. So this 50 mm we have to consider for the further calculation. So and this process is called as a design of the shaft. How to identify the statement? So for that purpose we have to read the statement carefully and in that we have to check whether shear stress is given or theta is given. If the shear stress is given, only first formula is applicable and along with shear stress if theta is also given, then we have to calculate the diameter by using the second formula also and we have to do the comparison. And maximum times this tau max, that is shear stress, and theta plays very important role in the diameter calculation. Why? Because maximum shear stress is the important value while designing of the shaft. Because maximum shear stress values are, if it is exceeds more than the limit, for example your shear stress value is 150 Newton per mm square, that is tau max. That means this 150 Newton per mm square, this is the maximum limit of that particular shaft. So we can apply the shear stress or that shaft can sustain the shear stress up to 150 Newton per mm square. मग हा shear stress जर 150 Newton per mm square आपल्याला इथपर्यंत जर तो शाफ्ट सस्टेन करायचा असेल तर त्याच्यासाठी आपल्याला किती डायमीटरचा शाफ्ट डिझाइन करावा लागेल. Therefore this tau max is important. Then how theta is important? Theta means angle of twist. If the shaft is rotating and there is a possibility of twisting due to some faulty application, getting जर तुमचा शाफ्ट लिमिट पेक्षा जास्त स्पीड जर फिरायला लागला तर देयर इज अ पॉसिबिलिटी ऑफ फेल्युअर. मग फेल्युअर कसं होणार आहे तर त्या शाफ्टचं मॅक्सिमम ट्विस्टिंग होणार आहे आणि तो शाफ्ट त्या ठिकाणी काय होणार आहे, ब्रेक होणार. फॉर एक्झाम्पल द shaft is twisting at 2 degree. The shaft is twisting at the 2 degree and this is the maximum limit. म्हणजे तुमचा शाफ्ट 2 डिग्री पर्यंत ट्विस्टिंग काय करू शकतोय, सस्टेन करू शकतोय. जर तो 3 डिग्री झाला तर इट विल गेट ब्रेक बिकॉज मॅक्सिमम लिमिट इज द 2 डिग्री. म्हणजे किती पर्यंत तो शाफ्ट तुमचा ट्विस्ट झाला पाहिजे, 2 डिग्री पर्यंत. दिस इज द मॅक्सिमम लिमिट. पण तो 2 पासून जर 3 डिग्रीला गेला तर देयर इज अ पॉसिबिलिटी ऑफ फेल्युअर. मग इफ माय थीटा व्हॅल्यू इज 2 डिग्री then what is the diameter of shaft? That we have to calculate. Means we are designing the shaft for the particular value or for particular application. Therefore this shear stress value and the angle of twist value plays very important role in the diameter calculation or in the designing of the shaft. Okay, so these are the two concepts. ह्याच्यामध्ये वेगळा फॉर्म्युला कुठलाच वापरायचा नाही. तोच टॉर्शन फॉर्म्युला दोन कॉम्बिनेशन मध्ये यूज केलाय. पहिल्या कॉम्बिनेशन मध्ये T/G is equal to tau upon r and second combination T/G is equal to g theta by L. This T/G it will be common for both the conditions. So you take this particular two formulas in your notebook, put the title Type number 2, design of the shaft in bracket, calculation of shaft diameter. Then formula number 1, T upon J is equal to tau upon R. In front of that, write down based on shear stress. T upon J is equal to tau upon R based on shear stress. Second formula, T upon J is equal to G theta by L based on angle of twist. T upon J is equal to G theta by L based on angle of twist. So for that purpose, we have to read the statement carefully. जर त्या स्टेटमेंट मध्ये फक्त टाउस दिला असेल तर सेकंड फॉर्म्युला विल नॉट बी ऍप्लिकेबल. बट इन द स्टेटमेंट इफ दे आर मेन्शनिंग द थीटा व्हॅल्यू, जी व्हॅल्यू अँड लेंथ ऑफ शाफ्ट also, then we have to clear that. We have to calculate the diameter by using the both conditions. Okay, so this is the formulas based on the shear stress and based on angle of twist. And then once again I want to explain that is maximum torque and the mean torque. So see, T upon J is equal to tau upon R is equal to G theta by L. So in this particular torsion formula, this T will be considered as a T max. And what is that T max? It represents the maximum torque transmitting capacity of the shaft. And for example, if it is 200 into 10 raised to 3 Newton mm, if this is the T max value, means I can easily say that the shaft can transmit the torque up to the 200 Newton per 200 into 10 raised to 3 Newton per mm without any deformation. If the T max value जर तुमची एवढी असेल तर मी काय सांगू शकतो की your shaft can transmit this much amount of torque without any deformation. Getting? आणि ह्याच्यापेक्षा जर तुमचा टॉर्कची व्हॅल्यू वाढली, there is a possibility of failure. Therefore, in the torsion formula, this capital T means T max. Then in the power formula, 2 pi nt divided by 60, and in this capital T means T mean, and this T mean value means the torque value which is calculated for particular given power. For example, 50 kilowatt power जर तुम्हाला दिले असेल तर ह्या 50 kilowatt power ला किती टॉर्क इंड्यूस झाला आहे, that we are calculating means this will be the T mean. Why it is important? Because sometimes in some of the statement the relation between maximum torque and the mean torque will be mentioned. In some of the statement, the relation between maximum torque and the mean torque will be mentioned, and that relation effect also we have to consider in the calculation. What is that relation? For example, maximum torque is 1.3 times mean torque is equal to 1.3 times T mean. Such relations they are mentioning in the statement. जर असं रिलेशन जर आपल्याला मेन्शन केलेलं असेल तर त्या ठिकाणी आपल्याला पहिल्यांदा हा पॉवरचा फॉर्म्युला वापर करून आपल्याला टी मीन ची व्हॅल्यू काढावी लागेल. ओके, आणि त्या टी मीन च्या व्हॅल्यूला जर आपण 1.3 न मल्टिप्लाय केलं तर यू विल गेट द टी मॅक्स, अँड दिस टी मॅक्स व्हॅल्यू वी हॅव टू यूज फॉर युअर फर्दर कॅल्क्युलेशन. प्लीज कीप इन माइंड. जर तुम्हाला डायमीटर काढायचे असतील आणि त्याच डायमीटरच्या स्टेटमेंट मध्ये इफ देयर इज अ रिलेशन बिटवीन मॅक्सिमम टॉर्क अँड द मीन टॉर्क, सो व्हॉट इज द फर्स्ट रिक्वायरमेंट? वी हॅव टू कॅल्क्युलेट द मीन टॉर्क by using the power formula, and by using the relation we have to calculate the Tmax, and that Tmax value we have to use for your further calculation. जर if there is no any relation in the statement, जर तुमच्या स्टेटमेंट मध्ये जर रिलेशन दिलेलंच नसेल, then what we have to do? Which will be the Tmax and which will be the Tmin? Can anybody? If there is no any relation in the statement, म्हणजे मॅक्सिमम टॉर्क and मीन टॉर्क मध्ये जर रिलेशन दिलेलंच नसेल तर what we will consider? Yes,
Both are equal.
correct. If there is no relation means Tmax is equal to TB. बघा प्रॉब्लेम नंबर 2, टाइप नंबर 1, प्रॉब्लेम नंबर 2. याच्यामध्ये काय दिलं होतं बघा, आपल्याला टॉर्क दिला होता, बरोबर. देयर इज अ टॉर्क किती दिला होता, सॉरी दिस इज द प्रॉब्लेम नंबर, yes, power transmission. Here power is given, okay, or torque is given. No, this is not. Okay, same this problem also we can consider. So here in the power formula 2 pi nt divided by 60, but if you read see this particular statement, ह्या स्टेटमेंट मध्ये आपल्याला कुठल्याच प्रकारचं रिलेशन दिलेलं नाही. म्हणजे आपण ह्या ठिकाणी काय केलंय, तर we have calculated this particular torque value first, we have calculated this particular torque value first, आणि हीच टॉर्क व्हॅल्यू आपण पॉवरच्या फॉर्म्युलेमध्ये ठेवलेली आहे. पण हा जो टॉर्क असतो capital T is equal to pi by 16 into tau max into d cube, whether this is mean torque or maximum torque. This will be the mean torque or the maximum torque. Condition is not mentioned. जरी कंडिशन दिली असती तर हा टॉर्क कुठला असला असता,
mean,
how it is mean,
maximum,
maximum torque. कारण हाच फॉर्म्युला बघा, T upon J is equal to tau upon R. हा फॉर्म्युला वापर करून पण आपण टॉर्क काढू शकतो, आणि हा फॉर्म्युला म्हणजे तुमचा हा फॉर्म्युला, आणि टॉर्शनच्या फॉर्म्युलेमधला जो काही टॉर्क असतो दॅट विल बी द मॅक्सिमम टॉर्क. आणि इथं पण तुम्हाला दिसतंय टाउ मॅक्स दिलेला आहे. जर हा टाउ मॅक्स असेल तर हा पण तुमचा maximum torque असणार आहे. But here they have not mentioned the conditions, but sometimes in some of the statement they are giving the relation between the maximum torque and the mean torque. जर असं रिलेशन दिलेलं असेल तर त्या ठिकाणी आपल्याला फक्त काय करावं लागणार आहे बघा, पॉवरचा फॉर्म्युला वापरून आपल्याला टॉर्क काढावा लागणार आहे. तो मिळणार आहे तुमचा टी मीन, आणि त्या टी मीन व्हॅल्यूला इथं काहीतरी एक मल्टिप्लाय फॅक्टर दिलेला असतो. जसं इथं रिलेशन मी सांगितलेलं आहे, टी मॅक्स इज इक्वल टू 1.3 टाइम्स इंटू टी मीन. त्या टी मीनला हा 1.3 न मल्टिप्लाय करायचं आहे, आणि आलेला आन्सर that will be the T max. That T max value we have to use for your further all the calculations. But if there is no any relation between the mean torque and maximum torque, बघा इथं जर मी रिलेशनच दिलं नसेल, मग माझा पॉवरचा फॉर्म्युला काय येणार, 2 पाय nt डिवाइड बाय 60. म्हणजे मी तर टी मीन लिहिणारच नाही. मग ह्याच्यावर जो काय मला टी ची व्हॅल्यू होणार आहे, दॅट टी विल बी मीन्स युअर टी अपॉन जे इज इक्वल टू टाउ अपॉन आर. जो पॉवरचा फॉर्म्युला वापरून जो काही टॉर्क व्हॅल्यू आलेला आहे ती आहे अशी टॉर्कची व्हॅल्यू मी काय करणार आहे, टॉर्शन फॉर्म्युलामध्ये वापरणार. Therefore you have to read the statement carefully. If they are mentioning the word maximum torque is this much time mean torque, maximum torque is 20% greater than mean torque, if this is mentioned means there is a relation given in between maximum torque and the mean torque. If relation is given, then we have to write down the formula of power in the form of T mean. जर रिलेशन दिला असेल तरच हा पॉवरचा फॉर्म्युला इन द फॉर्म ऑफ टी मीन मध्ये काय करायचा, लिहायचा, आणि हा टॉर्शनचा फॉर्म्युला टी मिक्सच्या फॉर्म मध्ये लिहायचा. जर रिलेशन दिलंच नसेल तर यू हॅव टू कीप दिस पर्टिक्युलर फॉर्म्युला ऍज इट इज इन द फॉर्म ऑफ कॅपिटल टी. हा मीन वर्ड त्याच्यामध्ये मेन्शन करायचा गरज नाही, किंवा ह्या टॉर्शनच्या फॉर्म्युलेमध्ये पण हा मॅक्सिमम वर्ड मेन्शन करायचा गरज नाही, बिकॉज कॅपिटल टी इज इक्वल टू टी मॅक्स इज इक्वल टू T. Getting? So for that purpose your statement understanding is very very important. We are solving the problems, we will solve the problem based on this. कसं स्टेटमेंट मध्ये दिलेलं असतं आणि कसं स्टेटमेंट मध्ये दिलेलं नसतं, that we will check while solving the numerical. But before that just I want to clear the things. कधी मॅक्स आणि मीन वर्ड वापरायचा आणि कधी that will not be considered in the formula, that we have to understood first. Getting the difference between the maximum torque and the mean torque, where we have to consider. Yes, have you understood?
Yes, sir.
T mean means power formula, T max means torsion formula. If relation is there, then we have to represent T mean in the power formula. त्या T ला फक्त खाली mean लिहायचा आहे आणि टॉर्शनच्या फॉर्म्युला फक्त मॅक्सिमम लिहायचा आहे. जर रिलेशनच दिलं नसेल ते दोन्ही पण वर्ड नाही लिहिले तर चालतील कारण कॅपिटल T इज इक्वल टू T max इज इक्वल टू T. Okay, so we'll solve one problem and then you will understand. See, this is the problem number 1. See, we will read the statement first. We'll understood the statement and then we'll go for the solution. See, a hollow shaft of external diameter 120 mm. A hollow shaft having external diameter 120 mm transmit 300 kilowatt power at 200 rpm. That shaft having external diameter, their internal diameter is not given. Transmit the 3 kilowatt power at 200 rpm. Full stop. Determine internal diameter. त्या hollow shaft चा आपल्याला internal diameter find out करायचा आहे. If maximum stress in the shaft not to exceed 60 Newton per mm square. Now here you have to, if you read the statement carefully, here we have to calculate the diameter. Clear cutly they have mentioned. Determine the internal diameter. Means this problem we have to solve based on the type number 2, that is design of the shaft. That we have to clear. And now if we will focus on the some another parameters, external diameter is given 120 mm, power is given 300 kilowatt, their rotating speed is given in the rpm 200, tau is given as the 60 Newton per mm square, and they have asked to calculate the internal diameter. Immediately you have to think about that whether this problem we have to solve based on the shear stress concept or angle of twist concept. कारण त्या दोन्ही फॉर्म्युलापैकी फक्त एकच फॉर्म्युला आपल्याला त्या ठिकाणी यूज करायचा आहे. मग दिलेल्या गिव्हन पॅरामीटर्स आपल्याला आयडेंटिफाय करायचं की वेदर फॉर्म्युला नंबर 1 इज ऍप्लिकेबल और वेदर फॉर्म्युला नंबर 2 is applicable. Now my question is that according to this particular statement, we have to solve the problem based on the shear stress concept or angle of twist concept.
Shear stress.
Shear stress, because if you check the statement, ह्या स्टेटमेंट मध्ये थीटा ची व्हॅल्यू, कॅपिटल जी ची व्हॅल्यू, कॅपिटल लेंथ ची व्हॅल्यू किंवा लेंथ ऑफ शाफ्ट ची व्हॅल्यू कुठंच मेन्शन केलेली नाही. जर अँगल ऑफ ट्विस्ट पासून जर आपल्याला काढायला सांगितलं असतं तर त्या तिन्ही पण व्हॅल्यू त्या स्टेटमेंट मध्ये आपल्याला दिल्या असत्या. But they have not mentioned, means we have to design our shaft or we have to we have to calculate the diameter. We have to calculate the diameter by using the shear stress concept only. In addition to that, they have not mentioned any relation between the maximum torque and the mean torque. They have not mentioned any relation between maximum torque and mean torque, means capital T is equal to T max is equal to T min. Okay, now first of all we will write down the given. See, given is equal to capital external diameter for hollow shaft. For hollow shaft, external diameter is equal to 120 mm. Transmit the 300 kilowatt power. This is 300 kilowatt. Immediately convert in watt, that is into 10 raised to 3. Then RPM RPM is 200 RPM. Shear stress value is also given 60 Newton per mm square, and we have to calculate their internal diameter. So these are the given parameters which is mentioned in the statement, and through this particular given parameters, first thing we have to clear, that is we have to calculate the diameter by using the shear stress concept or by using the angle of twist. but angle of twist, modulus of rigidity, length of the shaft are not mentioned in the statement. That means we have to use only one formula, that is based on the shear stress. Okay, so this is the requirement. Now, but if we have to use the formula, what is the shear stress formula? T upon J is equal to tau upon R. Okay, so here the J value is given, capital R, means here we have to write the formula for the hollow shaft, means instead of R I will write down the RO. Capital RO is also given, external diameter 123. J pi by 32 capital D raised to 4 minus DI raised to 4, म्हणजे त्या ठिकाणी DO पण दिलेला आहे, DI आपला अननोन पॅरामीटर आहे, but capital T is not given. Capital T is not given. Then how to calculate this capital T? Which formula we have to use here?
Power formula.
Power formula we have to use. So see, capital P is equal to 2 pi n T. Need not required to write down the T mean. किंवा ह्या टॉर्शनच्या फॉर्म्युल्यामध्ये need not required to write down the T max because relation is not given. Therefore 2 pi n T divided by 60. So put the value. Power is given in kilowatt. We have converted in watt. That is 300 into 10 raised to 3 is equal to 2 into pi into n, 200 into this capital T as it is divided by 60. So you will get one answer. What is that? If I will write down the formula in the form of capital T, so T is equal to 300 into 10 raised to 3 into 60 divided by 2 into pi into 200. So you will get the torque value
14.32 into 10 raised to 3.
14.32.
Yes, 14.32 into
10 raised to
10 raised to 3.
What is the unit? What is the unit?
Newton mm.
Newton mm.
Again, you are making the mistake. If power is in watt in the torsion
Newton
formula, sorry, in
meter.
the Newton meter, this is very important. If we have kept the power value in watt in the power formula, you will get the torque value in Newton meter. And again, you have to multiply by 10 raised to 3. That is 14.32 into 10 raised to 6 Newton mm. Please keep in mind. So write down or do the calculation in your notebook and send your answers in the chat box for my verification. The first answer you will get 14.32 into 10 raised to 3 watt. This is the wrong. Unit of the torque is Newton meter or Newton mm. Unit of the torque is Newton meter or Newton mm. That is force into perpendicular distance. It is not in watt. Everyone please do the calculations and send your answers in the chat box. Capital T is equal to 14.32 into 10 raised to 3. This is the first answer and it is in Newton meter. But if we have to convert it in Newton mm, again you have to multiply by 10 raised to 3. But first 10 raised to 3 and second 10 raised to 3, it will become 10 raised to 6. And then I have written the value of 14.32 into 10 raised to 6 Newton mm. That is capital T is equal to T max is equal to T min is equal to 14.32 into 10 raised to 6 Newton mm. So write down this sentence also. As there is no any relation between maximum torque and the mean torque, आलेली टी व्हॅल्यूज आपण मॅक्सिमम पण कन्सिडर करतोय आणि आलेली टी व्हॅल्यूज आपण मीन टॉर्क पण कन्सिडर करतोय. डोंट फॉरगेट टू डू द मल्टिप्लिकेशन of 10 raised to 3 in order to convert the value from Newton meter to Newton mm. If you are not converting, if you are not converting and if you are using that Newton meter value as it is for the further calculation, your diameter calculation also becomes wrong. त्यामुळे तुमच्या नोटबुक मध्ये किंवा त्या फॉर्म्युलेच्या शेजारी किंवा ह्या प्रॉब्लेमच्या शेजारी कुठेतरी लिहून ठेवा. In the power formula, if the power is in watt, you will get the T value in Newton meter, and you have to multiply by 10 raised to 3 once again to convert it from Newton meter to Newton mm. Okay, now the torque value we have calculated because this is our requirement in the torsion formula. Now see, now based on shear stress concept, we are having the formula T upon G is equal to tau upon Rho. In front of that run hollow shaft. Always try to take the Rho. जर तिथे solid shaft असेल तर the Rho लिहायची गरज नाही. If there is a hollow shaft, you have to write down only Rho. Don't take Ri. So now put the value. Capital T 14.32 into 10 raised to 6 divided by J pi by 32 in bracket do raised to 4 minus di raised to 4 is equal to tau value. What is the tau value? 60 divided by Rho means do divided by 2. Go for more and more simplification. 14.32 into 10 raised to 6 divided by pi by 32 do raised to 4. आपल्याला एक्सटर्नल डायमीटर दिलेला आहे स्टेटमेंट मध्ये. Therefore 120 raised to 4 minus di raised to 4 as it is, because we have to calculate, is equal to 60 as it is divided by do by 2. 120 divided by 2 means it becomes 60. Okay, so like that we have to do the calculation. Then again more simplification. 14.32 into 10 raised to 6 into, now denominator side la pi by 32 is present. Okay, the 32 is present at the denominator side. हे जर 32 मी जर वरच्या बाजूला घेतलं तर ते काय होणार आहे? मल्टिप्लाय होणार आहे का डिवाइड होणार आहे?
multiply.
Therefore take this 32 at the numerator side. बघा इथे डिवाइड 2 वेळा डिवाइड आहे, म्हणजे पाय बाय 32 व्हॅल्यू ऑलरेडी डिनॉमिनेटर साइडला आहे आणि त्याच्यामध्ये परत हे 32 अजून एकदा डिनॉमिनेटर साइडला, त्यामुळे ते वर जर घेतलं तर इट बिकम्स मल्टिप्लाय. डिवाइडेड बाय पाय इन ब्रॅकेट 120 raised to 4. 120 raised to 4 keep as it is minus di raised to 4 is equal to 60. It will get cancelled. Here it remains only 1. Okay, now what I will do, I will take unknown parameter at one side. आता हा di raised to 4 हा इकडच्या बाजूला डिनोमिनेटर साइडला, पण तो आपल्याला अननोन आहे, त्यामुळे तो पॅरामीटर आपल्याला काय करायचा आहे? एका साइडला घ्यायचा. बघा व्हॉट आय विल डू, 14.32 into 10 raised to 6 into this 32 divided by pi. मी फक्त di raised to 4 इकडे लेफ्टला घेऊ शकत, राईटला घेऊ शकत नाही, कारण काही टोटल टर्म आहे. बघा 120 raised to 4 minus di raised to 4, त्यामुळे मी टोटल टर्म जर राईट साइडला घेतली तर इकडच्या बाजूला असताना ती डिनॉमिनेटरच्या साइडला किंवा डिवाइड आहे, इकडच्या बाजूला आली तर ती मल्टिप्लाय होणार. मग 1 into म्हणजे राहिली काय फक्त तुमची 120 raised to 4 minus di raised to 4. Do the separate calculation of this term. काय ते सांगा. 14.32 into 10 raised to 6 into 30 divided by pi. What is the value of this term?
145.86 into 10 raised to 6.
Okay, 145.86 into
10 raised
10
to
raised to
6.
6.
10 raised to 6 is equal to this 120 raised to 4 as it is minus di raised to 4 as it is. Now I have to calculate the di raised to 4 value. बरोबर आहे. आता इकडे राईट साइडला असताना di ची व्हॅल्यू ही निगेटिव्ह आहे. बघा मायनस di raised to 4 आपल्याला काढायची आहे डायमीटरची व्हॅल्यू आणि डायमीटर इज नॉट इन निगेटिव्ह. डायमीटरची व्हॅल्यू कधीच निगेटिव्ह मध्ये नसते. जर ती व्हॅल्यू मला पॉझिटिव्ह करायची असेल तर व्हॉट आय हॅव टू डू. ही di raised to 4 व्हॅल्यू जर मला पॉझिटिव्ह करायची असेल तर व्हॉट आय हॅव टू डू.
Multiply by -1.
नो वाय मल्टिप्लिकेशन इज
साइड ला घ्यायचं.
हा जर मायनस di raised to 4 जर मी इकडे लेफ्ट साइडला घेतली तर ती काय होणार आहे पॉझिटिव्ह होणार आहे. इकडे असताना ती मायनस di आहे ती जर मी लेफ्ट साइडला घेतली तर इट विल बिकम्स प्लस di. That's why the equation will be right as it is, that is di raised to 4 is equal to 120 raised to 4. आता ही टर्म आहे कुठली 145.86 into 10 raised to 6 ही लेफ्ट साइडला असताना काय साइन नाही म्हणजे काय पॉझिटिव्ह आहे. जर ही जर व्हॅल्यू मला इकडे घ्यायची असेल तर ती काय होणार आहे पॉझिटिव्ह राहणार का निगेटिव्ह होणार आहे
Negative.
So 145.86 into 10 raised to 6. Then tell me the value of di raised to 4.
61.5
61.56 into 10 raised to 6.
61.56 into 10 raised to 6. This is in the form of di raised to 4 व्हॅल्यू म्हणजे 120 raised to 4 करा त्याच्यातून ही व्हॅल्यू सबस्ट्रेट करा आलेली किंवा येणारी व्हॅल्यू तुम्हाला इन टर्म्स ऑफ di raised to 4 मध्ये मिळेल. देन वी हॅव टू कॅल्क्युलेट द di व्हॅल्यू. सो व्हॉट यू हॅव टू डू टेक square root 2 times. टेक स्क्वेअर रूट 2 टाइम्स म्हणजे ह्या आलेल्या आन्सरचं स्क्वेअर रूट घ्या आणि परत एकदा त्या आलेल्या नवीन आन्सरचं स्क्वेअर रूट घ्या. यू विल गेट द di व्हॅल्यू इज इक्वल टू व्हॉट इज आन्सर
88.55.
88.54 mm. This is the internal diameter. Do your calculation and send me the answers in the chat box whether you are getting or not. di raised to 4 च आपण di मध्ये कसं कन्वर्ट केलं तर दिलेल्या आन्सरचं पहिल्यांदा स्क्वेअर रूट घेतलं मग ते di स्क्वेअर च्या फॉर्म मध्ये गेटिंग आणि परत एकदा स्क्वेअर रूट घेतलं तर इट विल गेट इन द di. किंवा ह्या आलेल्या आन्सरला जर तुम्ही असं जरी केलं बघा di इज इक्वल टू 61.56 into 10 raised to 6 आणि त्याचा रेस टू टोटल आन्सरला रेस टू 1/4 जर केलं तर किती येते आन्सर बघा di raised to 4 हे जर आपल्या di मध्ये कन्वर्ट करायचं असेल तर आलेल्या आन्सरला रेस टू 1/4 केलं तर व्हॉट विल बी आन्सर whether it is same or different. Yes, same or different. Same. So you can follow any procedure. You can take the square root 2 times. तुम्ही जर एकदा स्क्वेअर रूट घेतलं तर युअर आन्सर विल बी रॉंग. एकदा स्क्वेअर रूट घेतलं तर तुमचं आन्सर वेगळंच येणार आहे. Because the term is available in the form of di raised to 4. It is not only di square. If it is di square, then you have to take the square root single times. But it is raised to 4, therefore you have to take the square root 2 times and then you will get the correct answer. Or whatever the answer you will get, to that answer you have to make raised to 1/4. आलेल्या आन्सरला फक्त raised to 1/4 करा. You will also get the same. That is di is equal to 88.54 mm. Yes, everyone has calculated. Send your answers in the chat box. I have given the detailed procedure. बघा प्रत्येक step I have explained. pi by 32. In that 32 I have taken at the numerator side Okay, this 60 it will get cancelled. Then I have taken unknown parameter at the right side. मग तो right side ला घेतल्यामुळे it will get multiply. Then whatever the terms are present at the left side, त्याचं calculation केलं 145.86 into 10 raised to 6. मग त्यामध्ये आपल्याला DI ची व्हॅल्यू पॉझिटिव्ह करायची असेल तर लेफ्ट साइडला घेतली आणि राहिलेली टर्म जी काही लेफ्ट साइडला आहे तीच इकडच्या बाजूला घेतली तर ती सबट्रॅक्ट होणार. Then you will get the answer in the form of DI raised to 4. Then take the square root 2 times or make rest 1/4 to the obtained answer. You will get the internal diameter. That is, internal diameter of the hollow shaft is equal to 88.54 mm. Is everyone has calculated? I have not received answer from all of you. What about others? Have calculated? Send your answers in the chat box. 88.54. Don't send answers without any calculation by checking the answers from the chat box. You have to do the calculation at your own and then send answers. 88.54 or 88.55 mm. Both the answers will be accepted, no problem. I have not received any responses from the A division students except girl students. What about others, whether they are doing the calculations or not? Do the calculation. This calculation is very, very important. It is very simple, but rearranging the terms, it is very important. Rearranging the terms, it is very, very important. If you are making the mistakes to rearrange the terms, will not get the correct answer. Therefore, check each and every step whatever I have written here. Check each and every step whatever I have written here. Okay, so this is the first problem where through this particular statement we have first understood that how to check the problem, whether it is based on the shear stress or whether it is based on the angle of twist. In this statement only shear stress, therefore it is based on the shear stress concept only. In addition to that, there is no any relation between maximum torque and the mean torque. Therefore, we have not mentioned that mean word and maximum torque word in the power formula and the torsion formula. And we have written capital T is equal to T max is equal to T min. And same torque value we have used for your further calculation. Okay. Now, next problem. See, same problem is there, but how they have mentioned the relation between the maximum torque and the mean torque, that we have to understood. See, a solid steel shaft. Solid means there is a solid in cross section. That means only one diameter is given. A solid steel shaft has transmit 75 kilowatt power. A solid steel shaft has transmit 75 kilowatt power at 200 rpm. Full stop. Taking allowable shear stress 70 Newton per mm square. Taking allowable shear stress 70 Newton per mm square. Find suitable diameter of shaft. There is a solid shaft means there is only one diameter, and that one diameter we have to calculate. In the previous problem, external diameter dila hota, internal diameter they have asked. But here the shaft is solid means there is only one diameter, and that we have to calculate. Full stop. बघा इथं संपलं तुमचं statement. If maximum torque transmitted at each revolution exceeds by 30%, if such statement, or if this maximum torque transmitted at each revolution is exceeded by 30%, if this is mentioned in the statement, then we have to just clear that there is a relation between the maximum torque and the mean torque. जर असा पर्सेंटेज मध्ये जर एक्सीड झालेलं रिव्हॉल्युशन जर तुम्हाला स्टेटमेंट मध्ये दिलेला असेल तर we have to clear that there is a relation in maximum torque and mean torque. मग काही वेळेला असं पर्सेंटेज मध्ये पण दिले जातं किंवा काही वेळेला डायरेक्ट स्टेटमेंट असतं maximum torque is 1.0 2 times mean torque. Maximum torque is 1.2 times mean torque. म्हणजेच आपल्याला त्याचा अर्थ असा डायरेक्ट लागतो की Tmax is equal to 1.2 into Tmin. असं पण स्टेटमेंट मध्ये तुम्हाला दिलेलं असतं. But sometimes they are giving like that. The maximum torque transmitted at each revolution is exceed by percentage. असं percentage मध्ये पण रिलेशन दिलेलं असतं. That percentage value we have to convert into this multiplying factor. Now first of all we have to just clear that problem is based on the shear stress concept only, because only shear stress is mentioned. There is no any angle of twist, there is no capital G, there is no length of the shaft. Therefore we have to solve this particular problem by using the shear stress concept only. So first of all I will write down the given power 75 kilowatt is equal to 75 into 10 raised to 3 watt. Okay, then N is equal to 200 rpm, tau 70 newton per mm square. Okay, and what relation they have mentioned? The maximum torque transmitted at each revolution is exceeded by 30%. What is the meaning of this? The maximum torque transmitted, that means 100% torque transmission is taking place. जो काही शाफ्ट आपण ज्या काही शाफ्ट इथे यूज केलेला आहे, ज्याचा डायमीटर आपल्याला फाइंड आउट करायचा आहे, त्याने जो काही टॉर्क ट्रान्समिट केलेला आहे, इट इज ऑलरेडी 100% ट्रान्समिटेड अँड इन ऍडिशन टू दॅट इट इज एक्सीड बाय 30%. दॅट मीन्स टोटल हाऊ मच टॉर्क इट इज ट्रान्समिटेड?
130.
130. Therefore here Tmax is equal to 100 plus 30 divided by 100 into Tmin, and therefore Tmax is equal to, what is this multiplying factor? 100 plus 30 divided by 100, not 10. What is this multiplying factor?
1.3.
1.3. 1.3 into Tmin. So this is the relation mentioned in the statement. मग काही वेळा हे रिलेशन डायरेक्ट स्टेटमेंट मध्ये दिले असतं. The maximum torque is 1.3 times mean torque. So we can take this relation as it is for further calculation. But sometimes they are mentioning like this, that is maximum torque transmitted at each revolution is exceed by 30%. मग पर्सेंटेज मध्ये जर दिला असेल तर त्यासाठी तुम्हाला Tmax is equal to 100 plus 30. जर ह्या ठिकाणी 25 दिला असतं 25%, तर what we have to do 100 plus 25. ह्या ठिकाणी जर 20% दिला असतं तर what I will do 100 plus 20 divided by 100 into Tmin. Means whatever the torque is transmitted by this particular solid shaft, it is 100% transmitted. जेवढा का टॉर्क ट्रान्समिट करायला पाहिजे होता तेवढा त्याला 100% ट्रान्समिट केलेला आहे. बट इन ऍडिशन टू दॅट एक्स्ट्रा 30% it will get transmitted by each revolution. म्हणजे तो ट्रान्समिट करताना त्यानं 30% एक्स्ट्रा टॉर्क काय केलेला आहे, ट्रान्समिट केलेला आहे. मीन्स 100 plus 30 it becomes 130 divided by 100 into T means, and you will get this multiplying factor as a 1.3. That means maximum torque is equal to 1.3 times mean. मग हा तुम्हाला कंडिशन कधी वापरायची आहे, जर दिलेलं रिलेशन हे पर्सेंटेज मध्ये दिला असेल. जर डायरेक्ट रिलेशन त्यांनी स्टेटमेंट 2 टाइम्स मीन टॉर्क आहे, असं रिलेशन तुम्हाला पुढच्या कॅल्क्युलेशन मध्ये काय करायचंय वापरायचं. And now in this particular statement there is a relation between the maximum torque and the mean torque. Then how I will write down the torsion formula? How I will write down the torsion formula? This is based on the shear stress. मग तो shear stress चा formula how I have to write? T upon J is equal to tau upon R. What change I have to made here?
Tmax.
Tmax. जर रिलेशन दिलं नसेल, keep this capital T as it is. If there is a relation, mention Tmax in the torsion formula. This is very important. ह्या टॉर्शनच्या फॉर्म्युलेमधला हा टी मॅक्सच असतो आणि पॉवरच्या फॉर्म्युल्यामधून आलेला टॉर्क हा टी मिनच. ओके, सो नाव दिस इज द रिलेशन. मग ह्याच्यामध्ये आपल्याला बघा जे 5/32 डी.
मग ओनली 30/100 करणार आपण.
येस,
व्हॅल्यू 30% दिले ना, मग फक्त आपण 30/100 करणार. 100 प्लस
नो 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 नो. हिअर दे हॅव मेन्शन द वर्ड एक्सीड बाय 30%. म्हणजे जेवढे काय त्या शाफ्टनं पॉवर ट्रान्समिट करायला पाहिजे होती तेवढी करून ती दिलेली टॉर्क ट्रान्समिटिंग कॅपॅसिटी 30% ने काय झालेले आहे, एक्सीड झालेले आहे.
100 कुठे मेन्शनच केला नाही.
See, the maximum torque transmitted at each revolution is exceed by 30%. म्हणजे याचा अर्थ त्या शाफ्टनं एक कुठली तर टॉर्क त्याने ट्रान्समिट करायला पाहिजे होता, तो ट्रान्समिट करून त्याचं प्रत्येक रिव्हॉल्युशनला इट इज एक्सीड बाय 30%. म्हणजे आफ्टर 100% ट्रान्समिशन एक्स्ट्रा 30% टॉर्क त्याने काय केलेला आहे, ट्रान्समिट केलेला. देअरफॉर 100 प्लस 30 डिवाइडेड बाय 100. You have to understand the meaning of exceed by. Exceed by means after satisfying their own condition त्याने काय तर ठराविक टॉर्क त्याने ट्रान्समिट करायचा होता, तो करून त्याने एक्स्ट्रा 30% ट्रान्समिट केला. मीन्स ही हॅज डन द एक्स्ट्रा वर्क लाईक दिस. गेटिंग?
येस सर.
सो दिस इज द टॉर्शन फॉर्म्युला टी मॅक्स अपॉन जे. मग ह्याच्यामध्ये टी मॅक्स आपल्याला फाइंड आउट करावं लागेल. टाऊ आपल्याला दिलेला आहे. कॅपिटल आर मीन्स युअर एक्सटर्नल डायमीटर डिवाइड बाय 2. जे पण हा तुमच्या एक्सटर्नल डायमीटरच्या फॉर्म मध्ये आहे. दॅट मीन्स देर आर टोटल 2 अननोन्स. म्हणजे डायमीटर पण अननोन आहे आणि टी मॅक्स पण अननोन आहे. सो फर्स्ट ऑफ ऑल वी हॅव टू कॅल्क्युलेट द टी मॅक्स. हाऊ टू कॅल्क्युलेट द टी मॅक्स वन्स अगेन? हाऊ टू कॅल्क्युलेट द टी मॅक्स? First of all, we have to calculate the T mean. P is equal to 2 pi n T divided by 60. Now here T I have to write in the form of T mean. So now put the values. 75 into 10 raised to 3 is equal to 2 into pi into 200 into T mean divided by 60, and T mean is equal to 75 into 10 raised to 3 into 60 divided by 2 into pi into 200. What is the T mean value?
3.58 into 10 raised to 3.
3.58 into 10 raised to 3. What is the unit?
Newton meter.
Newton meter. Don't forget to multiply by 10 raised to 3 once again. T mean is equal to 3.58 into 10 raised to 6 Newton PM. Everyone check your answers and send your answers in the chat box. I will check. Here there is a relation between T max and T mean. Therefore, in the power formula also, I have mentioned the value of T in the form of T mean, because T max is not equal to T mean. And how to identify? Because they have mentioned the torque transmitted capacity is exceed by 30%, or maximum torque transmitted at each revolution is exceed by 30%. Revolution per minute, it is applicable for the power formula. Revolution per minute, it is applicable for the power formula. त्यामुळे त्या प्रत्येक रिव्होल्यूशन मध्ये 30% न तुमचा टॉर्क काय झालेला आहे, एक्सीड झालेला आहे. त्यामुळे तुमचा टी मॅक्स आणि टी मीन हा कॉन्स्टंट राहणार नाही. दिस इज द मीनिंग ऑफ दिस 30%. पॉवर ट्रान्समिट करताना जो काही शाफ्ट तुमचा रोटेट होते प्रत्येक रिव्होल्यूशन, त्या प्रत्येक रिव्होल्यूशनला इट इज एक्सीड बाय 30%. Therefore, we have to consider the 3.58 into 10 raised to 3. It is in Newton meter. Again, some students are making the mistake. They are not mentioning the units properly. 3.58 into 10 raised to 6 Newton mm. This is very important. Multiply by 10 raised to 3 once again, and then write down the unit Newton mm. 3.58 into 10 raised to 3. This is the first answer in a Newton meter. And again, you have to multiply by 10 raised to 6. Sorry, again, you have to multiply by 10 raised to 3. Means 10 raised to 3, 10 raised to 3, it becomes 10 raised to 6. And your unit will be in the form of Newton mm. So this is the T mean value. This is the T mean value, but we cannot use this T mean value as it is in the torsion formula because we are having the second relation. But T max is equal to 1.3 into T mean. So put the value 1.3 as it is. So this 1.3 as it is, T mean 3.58 into 10 raised to 6. Therefore, T max. What will be the answer?
4.65 into
65 into 10
4.65
raised
into 10 raised to 6.
4.65 into 10 raised to 6. It is also Newton mm because already we have converted T mean value in Newton mm. So this is the T max value. Please check your answer. T max is equal to 4.65 into 10 raised to 6 Newton mm. And once you have calculated T max, we are having the formula as per shear stress concept. Again, we are having T max upon J is equal to tau upon R. So this is our main formula, torsion formula based on the shear stress. So put the value 4.65 into 10 raised to 6 divided by J. There is a solid shaft, so only one diameter. Pi by 32 into only capital D raised to 4 divided by tau. What is the value of tau? 70. 70 divided by capital R means capital D divided by. So this is the value. Now what I will do, once again, this 32 I will take at the numerator side. तसंच इकडच्या बाजूला पण D divided by 2 आहे. If you see at the right side, R means capital D divided by 2. हे 2 पण मी काय करू शकतो? वरती घेऊ शकतो. So what is your next step? 4.65 into 10 raised to 6 into 32 divided by pi as it is into d raised to 4 as it is equal to 70 into 2 divided by d. This is my value. Now what I have to do, I have to take all the unknown parameters at one side. बघा इकडच्या बाजूला पण d raised to 4 आहे आणि इकडच्या बाजूला पण small d आहे. That I have to take at one side. What I will do, 4.65 into 10 raised to 6 into 32 divided by this pi as it is. हे d raised to 4 लेफ्ट साइडला असताना डिनॉमिनेटरला आहे, ते जर मी राईट साइडला घेतलं तर ते काय होणार आहे, इकडे मल्टिप्लाय होणार आहे. तसंच 70 into 2 इट इज प्रेझेंट ऍट द राईट साइड, ते वरच्या बाजूला असताना न्यूमरेटरला आहे, ते जर मी लेफ्ट साइडला घेतलं तर इट विल गेट डिवाइड. दॅट इज 70 into 2 is equal to d raised to 4 upon capital D. What will be the solution? 4.65 into 10 raised to 6 into 32 divided by pi into 70 into 2.
338.31 into 10 raised to 3.
How much?
338.31
Into
10 raised to 3.
into 10 raised to 3. Okay. Is everyone has got this solution? Please send your answers in the chat box. 338.32 into 10 raised to 3. And what is the term present at the right side? बघा, at the numerator side d raised to 4 आहे. खालच्या बाजूला फक्त d आहे. 1d from the numerator, 1d from the denominator, it will get cancelled. मग left right side ला काय राहिलं फक्त? What is remaining at the right side?
D cube.
D cube. The d cube is equal to. So I will write the same equation in the form of d cube is equal to. You check your 338.31 into 10 raised to 3. Check this value whether you are getting or not. If you are able to do the direct simplification or direct solution, you can, no problem. But if you are unable to do the direct solutions, follow these particular procedures. Take all the unknown parameters at one side. Take remaining terms at the left side which are not required. 338.31 into 10 raised to 3 and ह्या आलेल्या आन्सरला जर कॅपिटल D is equal to 338.31 into 10 raised to 3 raised to 1/3 जर केलं किंवा in your calculator if there is a possibility of this direct term, जसं आपण square root घेतो, if there is a possibility of cube root, then you can take the cube root also from your calculator. Or if it is not there, then आलेल्या आन्सरला फक्त raised to 1/3 न और आलेल्या आन्सरला फक्त raised to 1/3 करा, you will get the correct answer. What will be the answer?
69.67 mm.
67. Yes, this is the final answer. This is the diameter of the shaft. So those who have not calculated, send me your answers in the chat box. 69.68 or 69.67, both answers are accepted. (69.67) or 69.68. So this is the basic difference between the problem number 1 and the problem number 2. In the problem number 1, there is no any relation between Tmax and Tmin. So whatever the torque value you will get from the power formula, तीच torque value आपण torsionच्या formula मध्ये use केली. But here in this particular statement, they have mentioned the relation. The maximum torque transmitted by each revolution is exceeded by 30%. असं जर पर्सेंटेज मध्ये दिलेलं असेल तर त्या पर्सेंटेज मध्ये 100 ऍड करा बिकॉज इट इज ऑलरेडी 100% ट्रान्समिटेड आणि एक्सीड झालेले व्हॅल्यू त्यांनी 30% मध्ये दिलेले. दॅट मीन्स 100 plus 30 divided by 100 it becomes 1.3 times. Or sometimes they are giving the relations directly. Tmax is 1.2 times Tmin. तर त्याच्यामध्ये काहीच करायची गरज नाही. टेक दॅट रिलेशन ॲज इट इज. मग असं जर रिलेशन दिलेलं असेल then we have to think that we have to calculate the Tmin separately from the power formula. Then we have to use the relation. We have to find out the Tmax value also because during the diameter calculation we have to use the Tmax. So तुम्ही Tmin चा वापर करून जर diameter find out केला तर that will be wrong. जर relation दिला असेल तर relation दिलेला आहे तुम्ही फक्त Tmin काढूनच तो ह्याचा पुढे वापरला calculation साठी तर it will be wrong. If there is no relation, automatically both values are same. Tmax is equal to Tmin. But if there is a relation, you have to use that relation for your calculation. So this is the both the problems we have solved based on the shear stress concept only because in the both the statement they have not mentioned theta value, g value and the length of the shafts. So they are not required to use the second equation that is T upon G is equal to G theta by L. but the process for both the numericals, it is same. T upon J is equal to tau upon R. The first problem is applicable for the hollow shaft, where one diameter is given, second diameter we have calculated. And in this particular statement, they have given the solid shaft. Therefore, only one diameter we have to calculate. But we have to read the statement carefully whether relations are there or not. If it is there, then how to use that relation for the calculation and kutla T kuta put up करायचा आहे, that we have to understood. Okay. Now have you understood the difference between the problem number 1 and problem number 2 and how to solve the numericals to design the shaft or to design the diameters or how to calculate the diameter? Yes, everyone, have you understood the process for the design of the shaft?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, what about others? Everyone have understood? If you have not understood any step, any procedure, any calculation, you can unmute and you can ask the question. Don't say only yes, yes. If you have not understood any step, you can unmute or you can send your question in the chat box. I will give the answer. But process is very simple. Same process will be applicable for all the problems, but only understanding of the statement is important. आणि त्याच्यामध्ये जर थीटा व्हॅल्यू वगैरे दिला असतील तर लगेच आपण थीटाचा फॉर्म्युला वापरू शकतो. बट वी हॅव टू गिव्ह मोर अँड मोर फोकस ऑन द रिलेशन बिटवीन टी मॅक्स अँड द टी मीन. कुठल्या फॉर्म मध्ये दिलेलं आहे ते पर्सेंटेज मध्ये दिलेलं असेल तर 100 प्लस दॅट पर्सेंटेज व्हॅल्यू डिवाइड बाय 100 यू विल गेट दॅट मल्टिप्लाय फॅक्टर. Or sometimes direct it is given in the statement T max is 1.4 times T min. You can use as it is, but don't forget to calculate the T min first from the power formula. Don't forget to make multiply by 10 raised to 3 from Newton meter to Newton mm conversion. तुम्ही जर ते विसरला तर तुमचे सगळे पुढचे कॅल्क्युलेशन रॉंग येणार आहेत. And then by using the relation we have to put the T max and then further calculation is simple. It may be solid shaft or it may be hollow shaft. Okay, so with this today we will stop here. The remaining problems that we will take in the next lecture. So I will give one more problem. So this is the problem in front of you. So take this particular problem for the exercise and solve it. If you check this particular statement, hollow shaft is transmitting power दिलेला आहे, RPM दिलेला आहे, shear stress not to exceed 65 दिलेला आहे. There is a relation between internal diameter and external diameter. Internal diameter is 6 times external diameter. बघा दोन्ही डायमीटर मध्ये रिलेशन दिलेलं आहे. पहिल्या डायमीटर मध्ये पहिल्या प्रॉब्लेम मध्ये आपल्याला एक्सटर्नल डायमीटर दिला होता आणि इंटरनल डायमीटर फाइंड आउट करायला सांगितलं होतं. बट हियर दे हॅव गिवन द रिलेशन DI is equal to 0.6 into DO. We have to use this relation for the calculation and find the external and internal diameter. Assume बघा इथं T max is 1.3 times T min. Directly they have mentioned T max is equal to 1.3 times T min, means we have to calculate the T min value and we have to calculate the T max value. Okay, take this particular screenshot or I will send this particular problem also on the WhatsApp group for your solution. Okay, so with this today we will stop here. Solve this particular problem, send me the solutions. I will check accordingly and I will give the replies whether it is correct or not. Okay, so with this we will stop here. Remaining the problems we will take in the next lecture.